Okay, let's talk briefly about why the unit tangent vector is, why the derivative of the unit tangent vector is perpendicular to the tangent vector. It comes out simply because the magnitude of the unit tangent vector is always the same. Anytime you have a vector of constant magnitude, then a picture of the change in this vector from one value of the parameter to another looks like this. Okay, and we're talking about a small change in the parameter so that these vectors are relatively close together. Okay, the change is this vector here because, of course, if you take the t of t vector and add the change in the t vector, you get the new t vector. Okay, so that the change, this vector represents this vector minus this vector. This vector minus this vector. Now let's consider if theta is, okay, and I'm going to call theta the angle between here and here. If the change in your parameter is very small, then the angle down here is going to be very small. Okay, now the angle down here is very small, and these three vectors, aligned as they are, form a triangle. Now I asked the question, what kind of a triangle is this? And people said right triangle. Well, it's kind of turns out pretty close to a right triangle, but not quite. And I finally dragged it out as somebody finally said isosceles. And yes, these two sides, these two vectors have equal magnitude, so that these two vectors are represented by equal lengths, so that this triangle is isosceles, meaning that the angle between the original vector and the change in t, and the angle between the change in t and the new vector, and those angles have to be equal. Also, this is a very small angle. The three angles have to add up to 180 degrees. Two of them have to be equal. One of them has to be really small. What's that tell you about the other two? It tells you that they're both close to 90 degrees. You certainly need to be sure that you understand that and can make that argument yourself. And in the limit, as delta t approaches 0, okay, as delta t approaches 0, this divided by the change in your parameter approaches the value of t prime. And as delta t goes to 0, this angle approaches 0, so that this angle here between the t vector and the delta t vector, which I call theta, that has to approach 90 degrees, as I indicated here, of course. And it follows then that the vector t prime is normal to your curve. It's not necessarily unit normal, that's why you have to divide t prime by the magnitude of t prime to get a unit normal. Okay? And that also leads us to the conclusion it's often easier to do the perpendicular component of A as opposed to the derivative of your t prime vector, which is kind of a hairy derivative. Not as bad as the derivative of this, but bad enough.